start the class now? Students, shall we start the class?
Yes, ma'am. Yes, ma'am.
Yes.
Okay, ma. Yesterday we discussed about EDTA method. EDTA method we discussed, ma. What are the chemicals we required for this experiment, and what are the samples we are taking? Okay, you have to remember this. We are using ethylene diamine tetraacetic acid. You can see, ma, here. Okay, ethylene diamine tetraacetic acid. All of you write the structure in your notebook first now. Write the structure in your notebook. Ethylene diamine tetraacetic acid. Structure of EDTA. Everybody write down. Ethylene diamine tetraacetic acid. Students, you wrote? Hello?
Writing.
Okay, ma'am. You write the structure. Ethylene diamine tetraacetic acid. Write the structure of EDTA. Okay, so we require the chemical EDTA, ethylene diamine tetraacetic acid, and you know the structure also. Okay, and we use the areochrome black tea indicator. This structure no need for you. I gave in PPT. This is the structure of EDTA. Okay, no need for you. This one structure just I gave you. So EDTA structure no need. Okay, but I gave in PPT just to understand what is EBT areochrome black tea indicator. That is 1,1-hydroxy, 2-naphthaliso, 6-nitro. Okay, 2-naphthol, 4-sulfonate. This is the structure, ma, but no need for you. Just remember EBT indicator, areochrome black tea indicator. And we prepare the buffer solution by taking ammonium chloride and ammonia. We will mix that both, and we prepare the buffer solution to maintain the pH 9 to 10. Okay, so why we have to maintain the pH 9 to 10 means under basic conditions only, EDTA will react with the calcium and magnesium and form a complex ion. So for that we need compulsory, we have to use the buffer solution. Okay, we prepare the here by taking ammonium chloride and ammonium hydroxide to maintain the pH 9 to 10. Then we are taking here 3 samples. One is a standard water. Next we will take tap water, water sample, and boiled water. Okay. Apparatus we use conical flask, burette, pipette, beakers. And we have to discuss the principle first. So yesterday we discussed. Don't make noise. Yesterday we discussed that EDTA is a hexadentate ligand. EDTA is a hexadentate ligand because it is having lone pair of electrons, 6 pair of lone electrons. Okay, lone pair of electrons, and it will donate these electrons. It will share the electrons to the metal ions, calcium and magnesium, and forms covalent bonds. So we discussed yesterday principle. Very simple, ma. We are taking a water sample, okay, containing hard salts, either calcium or magnesium. So we are adding in that water sample water, we are adding EBT indicator 3 drops. EBT indicator 3 drops. Okay, then we will add buffer solution. Buffer solution we will take 1 ml buffer solution. So immediately there will be color change will be taking place, ma. Wine red colored complex, because the EBT, it reacts with the calcium and magnesium present in water. Okay, if calcium and magnesium present in water, then only you will get wine red color. Otherwise, the sample of water, it will be blue color, because EBT is blue colored indicator. Okay, so if hard salt present in water, then only you will get wine red colored complex. So to this solution, that is wine red color solution, so we are titrating with the EDTA, ethylene diamine tetraacetic acid, by taking in the burette. Burette is 50 ml. So I told you already. So we will take the apparatus, that is 50 ml burette. 50 ml burette. We use, we will take EDTA in the burette. In the burette, we will take EDTA up to 0. We can fill. Okay, here it will be 50. Okay, up to 0, we will fill the EDTA, ethylene diamine tetraestic acid. That solution we will fill in the burette up to 50 ml. Okay, then we will titrate with the solution what we have taken here in the conical plasma, wine red colored solution. Drop by drop, we will add EDTA into the solution and we will observe the color change here. Slowly you can see when we are getting end point, nearer to the end point, you will observe that slowly the wine red color changes to blue color. Okay, so at 1 drop of EDTA, so suddenly the color completely it changes to the blue color. That indicates that all the calcium and magnesium that is reacted with EDTA and form a colorless stable complex. Colorless stable complex. When this colorless stable complex is formed means, so then nothing here, that water we can use. There is no harm to use that water because here a complex compound is formed in water. So this is like an internal treatment method. This is like internal treatment method. Okay. So calcium EDTA and magnesium EDTA. So that colorless stable complex is formed. Now there is no harmful for us to use this water. Okay. So there is a free release of ABT indicator so that we can observe the color change, that is wine red to blue. Now we will discuss the procedure. So procedure 4 steps are there, students. So first what we do in step 1. Step 1, we will take a standard flask. We will take a standard flask. So in that we will take 1000 ml water, distilled water. 1000 ml distilled water we will take in a standard flask. So we have to add 1 gram of calcium carbonate. 1 gram of calcium carbonate. So we have to weigh 1 gram of calcium carbonate. After taking the weight, we will transfer into 1000 ml standard flask. So in that we will take 1000 ml distilled water, means there is some standard mark will be there for that standard flask. Okay, 1000 ml standard flask. So there is a standard mark will be there. Up to that mark, we have to fill the distilled water. Up to that mark, we have to fill the distilled water. You can shake it nicely. You can dissolve the calcium carbonate. Okay, you can shake it nicely, and we can use that solution as a standard water. Okay, so make up the solution up to the mark. Mark is there in standard flask. So there is a mark will be there in standard flask. So up to that mark, you have to take the distilled water and you have to dissolve it and you can use as a standard water. Then we will find out in step 1. Step 1. What we are going to find out in step 1? Molarity of standard hard water. Molarity of standard hard water. So what is the molarity formula? Weight by gram molecular weight into 1000 by volume in ml. Weight by gram molecular weight into 1000 by volume in ml. So weight we have taken 1 gram. 1 gram of calcium carbonate. So by molecular weight is 100. Calcium carbonate molecular weight is 100 into 1000 by volume in ml. How much we prepared for 1000 ml? Okay, 1000. So 1 by 100 into 1000 by 1000. So we'll get here 0.01 molar. Okay, what is the molarity of standard hard water? Standard hard water, that is M1 is equal to, so M1 we will take it as molarity of standard hard water, that is 0.01 molar. So we prepared the first solution. We are taking 3 solutions, students. One is standard hard water. Okay, second one is tap water. Third one is boiled water. Step 1, we prepared standard hard water. We prepared standard hard water by taking in standard flask, that is 1000 ml standard flask. You have to take 1 gram of calcium carbonate. You have to dissolve in the distilled water and find out molarity of standard hard water by taking the formula weight by molecular weight into 1000 by volume in ml. So we got M1 is equal to, that is 0.01 molar. Okay, ma? So this is step 1. Now step 2 is, I think step 1 everybody understood. Students, what we do in step 1?
Students, finding molarity Oh, this is
Finding molarity of
standard hard water.
Hard water. Finding molarity of standard hard water. We are preparing a standard hard water, students. We are preparing standard hard water. And second step is standardization of EDTA solution. Standardization of EDTA solution. So what we do here is we will take here standard hard water, that is calcium carbonate solution. Okay. So in a conical flask, we have to clean the conical flask. So we have to pipette out 20 ml. Listen, pipette out 20 ml of calcium carbonate solution into a clean conical flask. Then add 2 ml of buffer solution. So 1 to 2 ml we can add, no problem. Add 2 ml of buffer solution and add 2 to 3 drops of EBT indicator. Add 2 to 3 drops of EBT indicator. So immediately we'll get a color wine red color. Wine red color, because we have taken a standard hard water. Standard hard water. Calcium is there. Okay, ma? Standard hard water. You will get a color change, wine red color. Okay. So what all you have to take in conical flask is you have to take 20 ml calcium carbonate solution, add 2 ml buffer, and add 3 drops of EBT. You will get wine red color solution. Now take EDTA in the burette. Always you have to take the EDTA in the burette only. Okay. So take EDTA solution in a burette. Okay. Then you can titrate. Okay, you can do titration with the wine red color solution until you get a blue color. Until you get a blue color. So after immediately when you get wine red color to blue color, stop the titration. Close the burette. Stop the titration. So note down in your notebook. Note down in your notebook burette reading. So if it is 20 ml of EDTA consumed, following me students, 20 ml of, hello?
Yes, ma'am.
20 ml of EDTA consumed means you can take here, you can write 20 ml. Okay, na? Understood, ma? Okay. So like that you have to do 3 times, ma. You have to do 3 times this one. Students, you are listening to the class, huh?
Yes, ma'am.
Yes, ma'am.
And now who is, I can see one face here, Ashraf, huh?
Yes, ma'am.
12, roll number 12. You are A section students, no?
Ma'am. CSE AMLA.
See, we completed this topic, students.
Long ago.
Yes, ma'am.
Yes,
I was
ma'am.
thinking.
CSE B students, they are having this topic, ma. Nobody is telling me. I am looking at Ashraf and I am thinking why this student is in B section. Hello. We completed, no, this one?
Yes, ma'am. Using hard water, boiled water. Step 4.
We completed this topic, yes or no?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Problems also we completed, no?
Yes, ma'am.
Yes, ma'am.
Ion exchange also we completed, no?
Yes, ma'am.
Nobody is telling that, ma'am, we completed this topic. Huh? You are listening nicely, whatever I am teaching for you. Problems also done, ma'am, in chat box. Okay. Shall I stop the topic now? Okay. We'll discuss the other topic. Students,
Okay,
means how many of you are listening to the class? I can understand now. Already we completed this and nobody is telling me. Just now I thought why Ashraf is there in this class. I am looking at Ashraf and thinking. Okay, okay, I will stop this. We'll take the other topic. So from 10 minutes, I am looking at Ashraf and why the student is here, because I can't see your faces now. That's what video should be on, ma. Problems will come like this only. Already when class started, students, already when class started, I thought that This class is A section only. I thought I have to teach potable water today, but suddenly I changed. I opened EDTA PPT and I started. Somebody is asked TikTok topics, no? So I'm thinking in that way. I opened this one suddenly. You have to tell me, ma. So students, you understood my yesterday's this ion exchange process?
Yes, ma'am.
This process you understood, no? Okay,
You
only you
completed
have to learn the reactions, ma. Okay, na? అందుకే వీడియో ఆన్ లో పెట్టుకోవాలి. నాకు అష్టాఫ్ ఒక్కడే కనిపిస్తున్నాడు. దీపక్ వెళ్ళిపోయింది ఇప్పుడు వీడియో. ఓకే, ఒక్కసారి అడ్వాంటేజ్ జస్ట్ ఐ విల్ రిపీట్ అడ్వాంటేజెస్, డిసడ్వాంటేజెస్, దెన్ we will discuss potable water. Okay, so advantages of ion exchange process, ma. Students, you understood, no? Yesterday's topic ion exchange. Hello.
Yes,
So
ma'am.
online class,
Yes,
this
ma'am.
problem only. Okay, so we can take highly acidic and alkaline water. Okay, ma. Then we can go for purification for this by this process, ma, ion exchange process. That is the advantage. So if it is water is highly acidic or highly alkaline water, also we can purify by this process. And hardness of water will be 0 to 2 ppm only. The soft water hardness, so that is 0 to 2 ppm. This water we can use, this is most suitable, ma. We can use in high pressure boilers, ma. The soft water. So what we get from ion exchange process, that soft water we can use in high pressure boilers. Now disadvantages are the ion exchange resins are expensive. Okay, because that what we are buying, what we are taking the chemicals here, either HCl, H2SO4, NaOH, or ion exchange bed, what we are buying, that cation exchange resin, anion exchange resin, so that are expensive. The ion exchange resins are expensive and cost of the purification is high. Okay, so here what one disadvantage here, raw water should not contain, hard water should not contain turbidity below 10 ppm. Hard water should contain turbidity below 10 ppm. If it is more than 10 ppm, because here that water is not clean water, like more clay will be there or mud will be there or any sand particles will be there. So that will be here that blocks the pores, ma, in cation exchange resin and anion exchange resin, and output of the process will be reduced. Okay, so that we have to see that the water what we are taking, hard water, that should contain turbidity below 10 ppm. Students, you understood, ma, this process clearly? So we take the hard water first in cation exchange resin, where exchange of cations, okay, like calcium and magnesium are exchanged with the cations of the like H plus ions from the cation exchange resin. So we will collect here the water containing HCl or H2SO4 from the first chamber. Okay, and cation exchanger bed that remains as R2Ca or R2Mg. Then we go for second chamber, that we are passing water from first chamber to second chamber, ma. So the water is containing now chlorides and sulfates. So now exchange of anion will be taking place, that is chloride ion with OH minus ions from the anion exchanger bed, and we will collect a pure water, soft water will collect that contains no anions or no cations in the hard water. Means completely we will collect the soft water containing only H2O. You can see, students, now the water contains only H2O. Okay, and anion exchanger bed, it is occupied with the chlorides and sulfates. So after doing for 10 hours, we have to go for regeneration. For cation exchanger bed, we will use regenerated solution. We will use dilute HCl that we are passing on cation exchanger bed, and again exchanging of the cation will be taking place, ma. That is H plus ion is exchanged with calcium. Okay, so we'll get in cation exchanger bed. Okay, that is RH. Okay, plus calcium chloride, that is the wastage that we are passing into through the sink, we are passing into the drain. and regeneration of anion exchanger bed, you have to pass the sodium hydroxide solution onto the anion exchanger bed, onto the anion exchanger bed, where exchange of the anion will be taking place, that is OH minus ion with chloride ion, and in you can get a fresh anion exchanger bed with ROH, fresh anion exchanger bed with ROH, and NaCl you can discard into the sink. Students understanding?
Yes, ma'am.
We'll go to the other topic now. Okay. Ashraf, you have
Yes,
to
ma'am.
tell me, ma. You have to tell me.
Ma'am,
Okay.
I thought that you were explaining again.
Again, ఎన్నిసార్లు చెప్తా నీకు class?
Even I thought that.
Everybody will think like that only. Okay. Now in your notes, write down. We are going to discuss students potable water. Write down, ma. Students, write down, ma. Students, now we can see. Write down, ma. Potable water. Potable water. In your notes, you write down, ma. New topic. Students, write down. New topic. Potable water. Specifications. Specifications. Steps involved in treatment of water. Steps involved in treatment of water. Disinfection of water by chlorination. Ozonization. Potable water. We will discuss specifications. Specifications. Steps involved in treatment of water. Steps involved in treatment of water. What are the steps involved in treatment of water? Okay, we are taking the 2 steps here, ma. Disinfection of water by chlorination. Disinfection of water by chlorination. Ozonization. Students, you wrote? What are the topic we are going to discuss? Potable water, its specifications, and the steps involved in treatment of potable water. Clear? Okay. Now, what is potable water means? So, potable water, it is also called drinking water, or we can call it as a municipal water, where municipality people, they will go for the treatment of the water, ma. We will use that water. Okay. From the municipality, we will collect the drinking water. So what are the treatment method is there to collect, to get a potable water? We will discuss the method now. We will discuss the steps now. So what is potable water means? Water that is free from contaminants. Water that is free from contaminants. Okay. Or water that is safe for human consumption. Water that is safe for human consumption is called potable water. Water free from contaminants. So no suspended particle should be there in water, or no colloidal particle should be there in water, or no pathogenic bacteria should not be there in water. Understood, ma? Water free from contaminants or water that is safe for human consumption is called potable water. Students, understood? What is potable water? What is potable water, ma?
Water that is
Water
free
from contaminants.
Water free from contaminants or water that is safe for
Human consumption.
human consumption is called potable water. So there should we will take some specifications, specifications of potable water. The water should be clear. The water should be clear, colorless, and odorless. Then only we can drink, yes or no? Okay. The water should be clear, colorless, and odorless. And turbidity should not exceed 10 ppm. Turbidity means what, ma? There should not be any clay particles. Okay. There should not be any sand particles. Okay. Like a suspended impurities. Suspended impurities present in water. Following me, students. Okay. The turbidity should not exceed 10 ppm. The hardness of water must be 125 ppm, not more than 125 ppm. The hardness of water must be 125 ppm. It should not exceed above 125 ppm for potable water. Okay, and pH must be 7.0 to 8.5. pH must be 7.0 to 8.5. Remember, the water should be free from heavy metals, like there should not be heavy metals in drinking water. Okay, the water should be free from heavy metals like lead, arsenic, chromium, manganese. Okay, so we should see that there should not be any heavy metals in drinking water. Okay, and dissolved gases like H2S and CO2. So there should not be any gases also like CO2, H2S, okay, in drinking water. And water should be free from pathogenic microorganisms. There should not be any pathogenic microorganisms in water. So we have to remove all bacteria present in water. Okay, so these are some of the specifications I gave you here. So you have to remember this, you have to study this, you have to remember, you have to write. When they will ask you to write the specifications of potable water, so you have to write this, because out of 7 marks question, if they will ask you specifications, they will give you 2 marks. Understood, ma? Okay. So first point, the water should be clear, colorless and odorless. And second point, the turbidity should not exceed 10 ppm. Means there should not be any suspended impurities present in water, like a clay or a mud particle, or you can take sand particles. The hardness of water must be 125 ppm, and pH must be 7.0 to 8.5. Okay, not more alkaline water or not acidic water. Okay, so we have to maintain a pH 7.0 to 8.5. And the water should not contain any heavy metals like lead, arsenic, chromium, and manganese, and also dissolved gases like H2S and CO2. And water should be free from pathogenic microorganisms. Okay, these are specifications of potable water. Students, hello?
Yes, ma'am.
Understood, ma? Specifications?
Yes, ma'am.
Yeah.
How much turbidity should be there?
Less than 10
be-
ppm.
Less than 10 ppm.
It should not exceed 10 ppm turbidity, like suspended impurities. What is the hardness of water should be?
125
125.
pH should be pH
7 to 8.5.
7 to 8.5. Okay. So it should not contain any dissolved gases, and also it should not contain any heavy metals. Okay. And it should be free from pathogenic microorganisms. Okay. This you remember points. Next, treatment of water for domestic purpose. Okay. So what are the steps we are following here? What are the steps involved in treatment of potable water? Okay. So municipalities have to supply potable water. The treatment of water for drinking purpose mainly includes, remember the students, mainly includes removal of suspended impurities, colloidal impurities, and harmful pathogenic bacteria. Okay, so for drinking purpose, okay, in potable water, what we remove when we are going for treatment methods means, treatment steps means, removal of suspended impurities, removal of colloidal impurities, harmful pathogenic bacteria. So what are the steps means? We will take the water, we will collect the water from one river, we collected water. Okay, na? Understood, ma? Sources of water. We go for first screening, ma. Screening. Next step, sedimentation. Third step, coagulation. Fourth step, filtration. Fifth step, sterilization, or it is also called disinfectation. Then we will collect that water, storage, we will store that water, and we will supply, distribution. Okay, so how many steps are there means? First step, screening. Second step, sedimentation. Third step, coagulation. Fourth step, filtration. Fifth step, disinfectation. How many steps are there, students? In treatment of potable water, how many steps are there? How many steps are there?
7 steps.
Steps are there. How many steps are there?
7.
5 steps are there. What is the first step? Screening, ma.
Sir.
First step is screening. Second step is sedimentation. Third step is coagulation. Fourth step, filtration. Fifth step is disinfectation. Okay. So first step is screening, ma. So screening is we have to do compulsory, because in water, in raw water, any impurities like floating matter, like leaves are there, any bark of wood is there. Okay, so that will be removed here in screening. So water is allowed to pass through the large mesh screen. So we'll take a large mesh screens, ma. So we'll pass through the mesh screens. So whereby we can remove the floating matter. Floating matter means like a leaf, so bark of the tree. Okay, any floating matter is there. Okay, so we can remove that one by passing through the large mesh screen. So that is the first step. First step is screening. Okay, in first step we will remove the large floating matter like leaves and bark of the wood. Okay, so next one is sedimentation. Sedimentation is very simple process. We will take a large tank. So we will pass the water in large tank. We will allow it for 2 to 5 hours without disturbing. We will allow it. Okay. So after 2 to 5 hours, all here you can see here in this picture, you can see in this diagram, you can see the suspended impurities that is settling down due to gravitational force, that is settling down at the bottom of the tank. At the bottom of the tank, and clear water you can collect with the pipe. Clear water we can collect with the pipe. So second step is here, water is allowed to stand undisturbed for 2 to 5 hours in big setting tanks. Suspended particles settle down here due to gravity, and clear water rises which can be drawn out with the help of the pumps. Okay, students, today we are stopping now. Only I told you about 2 points only. That also tomorrow I will revise again. Okay, so you have to remember, what you have to remember is what is potable water you have to remember, and specifications you have to remember. So tomorrow we'll start again. I will revise again these steps, first and second step. Okay, students, understood, ma?
Yes, ma'am.
ఏం చెప్పారు
Yes, ma'am.
Yes,
ఏం
ma'am.
చెప్పారు మీరు అసలు నాకు ఏం చెప్పారు ఇవాళ ఏం చెప్పారు ఓకే shall I end the class?
Yes, ma'am.
You understood now what is potable water?
Yes, ma'am.
Yes, ma'am.
What, ma'am? Some contamination.
3 impurities what are we are going to remove? First one is what? Students, first one is what?
Any floating impurity.
Suspended impurities we have to remove. Second one,
Colloidal
colloidal impurities. Third one,
harmful pathogenic.
harmful pathogenic bacteria. So that we have to remove. Okay. So tomorrow we'll discuss slowly again. Okay.